Okay, I put two problems up on the board for you to try here. So the first is I've given you a graph, and this is like the problem that we just did in the previous video. What I want you to do is find me the location and value of the absolute max, absolute min, any relative maxes and any relative mins, realizing that these things may or may not exist, and just complete this table. So that's your first task. I'm going to have you pause the video in a moment to do that. Okay. In fact, why don't you do that? Go ahead and pause the video, do just this problem, come back, we'll go over it, and then I'll talk about the second problem. Welcome back. Okay, so I'm going to just start reading left to right. If I look here, that's the highest point ever. Oops, I forgot to include a tick mark here. Okay, so that's my absolute max. It occurs at -2. And its value is 2. Again, I'm using the convention here that each tick mark is 1 unit. Okay. All right. If I come on down, this looks like an important point. Okay. It's definitely the location of a relative min, because if I look a little to the left and a little bit to the right, I don't see anything lower. So I can indicate that at -1, we've got a relative min of 0. Is it also absolute? Yes, because we never go lower than that. We approach 0, but we never hit it again. So that is an absolute min as well. Then I keep coming along, hit this point right here, and that's not the highest point ever, but if I look just a little to the left or a little to the right, I'm going to see that I don't see anything higher, so that's a relative max. So that occurs at 0 with a y value of 1. And then we just go down, but we never hit a lowest point, so that's it. So this one had 1 of everything. Okay, so the next problem, I'm asking you to draw me a function. Okay, so I want these 5 things to be true. I want it to have an absolute max of 3 that occurs when x is -1. I want it to have a relative min when x is 2. And I don't tell you how high that needs to be, but I do tell you that I want the derivative at 2 to exist. And then here, I want to have a relative min when x is 4, but I want the derivative at 4 to not exist. So we're sort of looking at what we know about the derivative at relative mins if it does or doesn't exist. Okay. I want it to have no absolute min and make the domain all real numbers. Now, there are infinitely many functions that have all of this behavior, so I don't expect you to get exactly the same one that I have. But what I want you to do is pause the video, try to come up with one. I'll show you one example. If you're not sure whether your example was right or not, just in office hours, come into office hours and you can upload a picture of what you did and I can comment on it then, or you're free to just email it to me as well. Okay? So pause and come back. Welcome back. Okay. So I'm going to keep in mind that the domain has to be R, but I'll just extend things at the end. So I want an absolute max of 3, and I want that to occur when x is -1. So I'm going to put a point there. And what I usually do if I have a max and I'm graphing is I just draw something to sort of indicate that that's a mountaintop. Okay? So that I know I'm going to come up and then come back down again when I hit that point. Now I want to have a relative min when x is 2, and I can decide how high or low I want that to be, but it has to be lower than 3 because that's my absolute max. So I think I'm just going to put it at 1. Okay. But I want f prime of 2 to exist. So I'm going to just draw in a little valley. As long as I make it nice and smooth and rounded so there's no sudden change, then the derivative is going to exist. And in fact, what would the derivative be at that min? Yes, it would be 0. Okay, we're going to have a horizontal tangent because that's the place we stop going down and start coming up, and so we're sort of leveling off in between. Okay. All right, then we want a relative min when x is 4. So I'm going to sort of go up a little bit and then come back down, but I want the derivative at 4 to not exist. So I think what I'm going to do is I'm going to make my min 0 here. Okay. But to make the derivative not exist, I'm going to make it a nice sharp corner. Okay. And then I want no absolute min, and I want the domain to be all real numbers. So I'm just going to extend this. If we go down towards negative infinity, there's going to be no absolute min. And then I just need to connect the pieces, making sure that I never go above 3. Now, if I wanted to come up to 3 at another location, I could, because I did not say that this needs to be the unique location of the absolute max. Totally fine if I want to hit at some other point. I don't think I want to, so I'll just do this, and like so. Now notice, there are some relative maxes in here as well. I did not say I was giving you all of the information. I just wanted all of the information about all the relative maxes and mins. I just wanted you to draw a function so that all of this was true. Okay. Your function could look very, very different from mine, but hopefully you've got some sense of what we're looking for. Really interesting to see that when the derivative exists, it's going to be a derivative of 0, giving us a horizontal tangent, because we're changing directions in a nice smooth manner. When the derivative doesn't exist, we're going to have a nice corner or a cusp. It's going to have to be a sudden change.